Alright, this is Preston video 1. So in this first problem we have to convert 5 terabytes to megabytes. Alright, so I had to Google this. I didn't know what the conversion was, but it turns out that 1 terabyte is 1,000,000 megabytes. So this will be a pretty quick problem. We're going to set up what we know here. This is 5 terabytes. And we're going to multiply it by a factor that will allow us to solve for megabytes. And I know that 1 single terabyte, like I said, is 1,000,000 megabytes. So, if I multiply this out, my terabytes will cancel, and I should end up with 5,000,000 megabytes.
Woo!
That's probably, the answer is probably a notation, so we're talking 5 times 10 to the 6th power megabytes. So I forgot to look at the answer to that one, but I bet you that's what it is. All right, on this next problem, we have to subtract 3.58 times 10 to the negative second power kilograms from 1.41 times 10 to the 11th nanograms. So we're looking at the difference between those values. So what's going to have to happen here? And we have to express our answer in grams. So we're going to have to take both of these measurements and get them into grams first. So here we go with our kilograms. Now, my factor for kilograms to grams is 1 to 1,000. You can recall that a kilogram, a hectogram, a decagram. Then you got your base unit, then your decigrams, your centigrams, and your milligrams. And then your micrograms is going to be out here, but that's actually a power of 3. And then your nanogram is another power of 3 from that. So this is all powers of 1 here. So for example, if I had 1 gram, it's 10 decigrams, 100 centigrams, 1,000 milligrams. But then you're talking, add 3 more zeros, 1,000,000 micrograms and 1,000,000,000 nanograms. So it works a little bit different out here. But anyways, let's take this first part. 3.58 times 10 to the negative second kilograms. We know that 1 single kilogram is 1,000 grams. So if I multiply this out, okay, here. Now learn how to use this calculator, or your calculator, whatever you're using. 3.58 second, use that double E button. It just means to the exponent. -2 times 1,000. And we're talking 35.8. All right, 35.8 grams is what the kilogram is equivalent to. All right, now your nanograms. Now there's going to be a few more steps here. So let's think about this. We need to get to grams. Now I would probably, you can do this in one step, but I like to go in steps here. So let's go nano to micro, micro to milli, and then milli to gram. We're going to do this in about 3 steps here. Let's see how this looks. So we're going to go, there are 1,000 nanograms in a single microgram. And then we know that there are 1,000 micrograms in 1 milligram. And then we know there's another factor here of 1,000 milligrams in 1 gram. So the way I got this set up, my nanograms cancel, my micrograms cancel, my milligrams cancel. If I multiply this out, I should be in grams. Let's take a look at that. 1.41, second power double E, 11. Divide by 1,000, divide by 1,000, divided by 1,000. All right, so divided by 1,000, divided by 1,000, divided by 1,000. Boom, 141. That's 141 grams. Okay, now going back to the problem, we have to take the kilogram value away from the nanogram value, but I got these both in grams now. So we're talking, taking away, subtracting this amount here from this one. So 141 grams minus 35.8 grams. Okay, now shame on me, I'm not going to get a calculator here. Let's see here, we're talking 2, all right, you're talking 5, talking 0 and 1, talking 105.2 grams. And let's see, if I'm following sig fig rules, I'm probably not going to worry about that 0.2, which is why that that answer is 105. So that's what's going on there. And that's about it. Hope that helps.